Hello, 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 and welcome to this beautiful Tuesday. I went into school yesterday. It was terrifying. I had to disinfect everything, both before and after I touched it. I had to stay 6 feet away from everybody involved. It was truly frightening. I will try not to do that ever again. Well, until this is over. Once this is over, I'm very excited to go back into school. I do miss my classroom. I miss that fish that turned into a mouse and tossing a Snoopy around. Yeah, and maybe some of the kids, some of you. Um, Squirrel is very happy that I'm home. She was very perturbed when I went outside. She made me wash my hands and scrub them well, and then she scratched them to make sure that they were scrubbed well. I told her that's not how it works. She's ridiculous. All right. So, what you should have done was you should have done our beautiful advanced proofs practice number 2. I did the back for you. All you had to do was the front. Some of you tried to do the front and the back over the weekend, so you were just checking over the back, and then you were good. Today I want to talk to you about parallel lines. Parallel lines, extremely important. So when we've got parallel lines form a whole bunch of angles when they are cut by a transversal. Without a transversal, parallel lines better not be forming any angles, because parallel lines better not be meeting. But once a transversal is entered in, then we've got a whole bunch of things going on. And there are 3 favorites that we talk about frequently. That would be alternate interior angles. Alternate interior angles would be if they're both inside our parallel lines. Our second would be alternate exterior angles, and that would be if they're both outside the parallel lines. So if one of them's up here and one of them's down there, that would be alternate exterior. And then our last one is corresponding angles. And that would be if one of them's inside and the other one's outside. So these are very, very important, and we went through an entire lesson, and we've gone back over this several times. If we have parallel lines cut by a transversal, that gives us a whole bunch of different angles. Well, today we're going to talk about what happens if we have these angles. If we have alternate interior angles and they are congruent, we can say that the lines are parallel. And that's going to be our mission today. Our mission today is to somehow get alternate interior angles or alternate exterior angles or corresponding angles. Because once we have those angles, we can prove lines are parallel. So let's take a look at this guy right here. We want to prove AB. So AB is right here. Notice, what am I using when I highlight AB? I am not saying that we know AB. I'm not saying we know CE. I'm using my sparkly gold crayon. And that's because we want to prove that those 2 lines are parallel. Do they look parallel? Yes. Will the regents accept they look like it as an appropriate reason? Absolutely not. So let's take a look at what they would accept for an appropriate reason. So we start with our statement reason chart, just like normal. Our mission is to prove those beautiful lines are parallel, but we need to start at a given. And we've got AE and CB are perpendicular bisectors of each other. Now that given is chock load of information. It's just so much information right there. So let's try to start unpacking that. AE and CB are perpendicular bisectors of each other. That's a given. Okay. So let's start with perpendicular. First thing, we've got a vocabulary word, so we need to do definition of that vocabulary word. Definition of perpendicular automatically means 90 degrees somewhere. There's a 90-degree angle somewhere, we just need to find it. That is what perpendicular means. Remember, perpendicular and bisector are two completely different words. Perpendicular means 90 degrees, bisectors mean chop in two pieces. So we've got AE and CB creating 90-degree angles. So all of these angles right here at D are going to be 90 degrees. Now, our mission is to find angles near our parallel lines. What we're going to do with this is we're going to zero in on this triangle right here and this triangle right here. Why would I zero in on those triangles? Why not this triangle? Well, if we take a look, I've got a transversal AE here, or I've got a transversal BC here. And this angle, where I've got gold sparkly goes to gold sparkly, would be in a pink triangle. I don't want to deal with this triangle and this triangle because that's not going to help me get angles next to my beautiful gold sparkly lines. I want angles right near my gold sparkly lines in order to prove parallel. So, although all of the angles at D are 90 degrees, you could write all of the angles out. But I'm only going to write the two that I care about. So measure angle ADB and measure angle CDE are both equal to 90 degrees and they're equal to each other. Okay, so we've got definition of perpendicular, very exciting. We've got a nice pair of angles right there. Now, did we need those beautiful angles? No. In fact, if we're looking at the pink triangle and the blue triangle, it might just be easier to say vertical angles there. The perpendicular, kind of useless to us. Hopefully the bisectors actually gives us something useful. So we've got bisector, which means we need, go down to here, definition of bisect. Now, they bisect each other, which means there are two different bisections going on. They're bisecting A and E, so A and E now split into AD and DE. And then let's talk about the other thing that's being bisected. Because they bisect each other, CB is also being bisected. So this guy and this guy just got chopped. So we've got BD and CD are also equal because of that bisection. Okay, we've finally gotten through that whole given. There were two different vocabulary terms, plus it was done to each other. So that's a lot of information. But if you notice, at this point, I can prove two triangles congruent. When you're dealing with a proof, particularly a complicated proof, just try and prove two triangles congruent. That's the easiest way to start a proof. Just put in your givens, see if you can prove some triangles. In this case, I can prove the pink triangle and the blue triangle. And I can prove that by side, angle, side, because that right angle is trapped between my two sides. So that gives me triangle ADB is congruent to triangle. Now, be very careful. I've seen a lot of you mess this up. So A is this point right here. The point that's going to match that with this one mark here is going to be E. Notice, when I did the angles, doesn't matter what order I put them in. So ADB and CDE, totally okay, does not matter which order they're in. But when you're dealing with triangles, make sure you stay consistent. So ADB, A matches with E, D matches with D, and B matches with C. Okay, we've proven two triangles are congruent. That's very exciting. Now what I need to do is, the whole goal of this was to prove that two angles were congruent. Once I've got my angles, I can backtrack to parallel lines. So I've got two beautiful triangles congruent. That means all of their sides and all of their angles are congruent. So I want to prove this angle and this angle are congruent. That means my transversal is going to be right there. So I've now gotten my side angle side, and I've proven the pink and the blue triangles are congruent. So angle B is congruent to angle C. So measure angle ABD is equal to measure angle ECD. And I've proven that this guy and this guy are equal by corresponding parts in congruent triangles are congruent. So I've proven the two triangles are congruent. Once I've proven the two triangles are congruent, I can steal those angles. Now that I've stolen the angles, I can finish this guy off by saying AB is parallel to CE. But be very careful. Unlike the last time we were doing this, and we could say definition of midpoint, we can't just say definition of parallel. We know that. We can never say definition of parallel. In this case, what we're going to say is congruent blank form parallel lines on the transversal. So if you remember, it used to be parallel lines form congruent blank on transversal. All I've done is I've taken this piece and I've flipped them. That's how we're going backwards. How we're saying, okay, I've got my angles, I can go backwards to parallel lines. So, going back to these parallel lines, are my triangles inside, outside? Is one inside, one outside? In this case, they're both inside my sparkly gold parallel lines. So they're going to be alternate interior angles. And that is how we prove two lines are parallel. We start by proving two triangles congruent, then we can get the angles next to them. The angles inside my triangles equal. And once we've got those angles inside my triangles equal, those angles that are actually next to my parallel lines, I can make the leap to parallel lines. So let's take a look at what another one looks like. I don't like that one. We're going to go down to the homework. Yeah, I like, let's do number 1. Number 1 looks fun. I'm going to do a nice statement and reason chart and start with my givens. AB equals DE. So AB equals DE by given. AB equals DE by given. Okay. AC equals DF. So AC equals DF by given. So AC equals DF by given. And then finally we have measure angle A equals measure angle D by given. Well, that just handed us 2 triangles. It just plopped 2 triangles in our lap and said, I'll leave these here. Have fun. That's going to be what? Side angle side? And it's going to say that triangle ABC is congruent to, now be very careful, in this case, it is going to go DEF, but sometimes they'll flip it just to be annoying because it's the regents. So this one is going to be A goes to D, B goes to E, and C goes to F. Now, let's take a look at my beautiful sparkly lines that I want to make parallel. When I take a look at my beautiful sparkly lines that I want to make parallel, there's only one transversal in this case. Now, I have just proven this beautiful pink triangle right here is congruent to this beautiful blue triangle over here. Now, that would get me angle E matches with angle B, and angle F matches with angle C. Which pair of angles is going to help me get to my sparkly gold lines? And of course, Squirrel has given up on me. Squirrely! Squirrel! She must be napping. Silly goofball. This is why I can't teach Squirrel proofs. She does not have the attention span. She just doesn't. All right. In this case, in order to get to my gold sparkly lines, I'm going to want to prove that C is congruent to F. So measure angle BCA is equal to measure angle DFE, because corresponding parts in congruent triangles are congruent. Yay! Now that I have this angle and this angle, that goes from sparkly gold to sparkly gold. So we've got a nice pair of angles going from sparkly gold to sparkly gold. Because I've got those pair of angles going from sparkly gold to sparkly gold, that proves that BC is parallel to EF, because congruent blank form parallel lines on transversal. And in this case, let's shade inside my parallel lines. Are my triangles inside, both outside, one inside, one outside? What's happening? They're both outside, making them alternate exterior angles. And that is how we do number 1. Your mission is to try and do number 2 and number 3. I want you to try and do number 2 and number 3 for me. See what you can do. See what you got. Be very careful. This symbol does not mean bisect. I cannot stress that enough. That symbol does not mean bisect and never will. It means perpendicular, and it means that there are 90-degree angles somewhere. Good luck finding them. All right, and that's what I have for you today. Thank you for tuning in to this episode of Izzo apparently teaching myself proofs because Squirrel won't even bother. I tell you, she's a diva, that squirrel. I'm guessing she's on strike to demand more treats. That's not good. I don't know if I can afford more. Well, I've got more treats. I might have to break out the reserve treats. Wish me luck. Adios. I'll give you an update tomorrow on how that strike is working.